Okay, good evening, everybody. Thank you for attending our talk. We're going to talk about data challenges and evolution of data at Nubank. So let's introduce ourselves first. So my name is Pepijn. I joined Nubank in 2016, but before joining it, I worked at a microjournalism startup in Holland called Blendel. And what I did there is I got my first experience working with data warehouses, data modeling, building ETL pipelines, all these things. Yeah, and then a bit of an odd thing, perhaps, but after Blendel, I went back to university because I was actually studying medicine, and I managed to get my bachelor's there, but it's unclear, like, what is the value of a bachelor in medicine? Like, does it mean I'm a doctor or not? Well, I still have to do my master's. I sort of got stuck here. So yeah, I technically didn't drop out because I have my bachelor's, but at the same time, against popular belief at Nubank, I'm also not a doctor. So I can't help there. What I can help with is data problems. So after joining Nubank, or after finishing my bachelor's in medicine, I went to Brazil, to Nubank, and almost immediately I joined a data squad again, where I helped in the beginning with building the ETL pipelines to get the data from our source microservices into our analytical environment to be used by machine learning models, BI applications. And so recently, the last 8 months, I've been working closely and building the Data Analyst chapter. And our goal is to simplify data access for everyone at Nubank. I'm going to tell more what that means later.
Hello, everyone. Good evening. I'm Talita. And just as Pepe, I also don't come from an engineering background. So my major was in actually international relations at São Paulo University. And from that, I started working in 99 as with relations with the government. And there I started dealing with the data warehouse, extracting data from our data warehouse, and that's how I fell in love with data. So from that, I had several more analysis-focused roles in several places, went to Python, data cleaning, and I started here at Nubank as a data analyst, so 8 months ago in the data access squad, actually with Pepe back then. Currently, I'm also a mentor in Udacity in the Data Analyst nano degree, and I'm also a member of the Minas Programa project, which is really nice. Check it. It's an initiative that incentivizes and encourages women in technology. Okay, so I can pass. Thanks. So for today's agenda, first we're gonna give a quick overview in how teams are organized here at Nubank. So basically our squad and chapters model. After that, we're gonna check a little bit how squads and chapters relate to data and the decisions that we made in data and data modeling over the past few years. And as a consequence, getting into more details about the data analyst chapter. Okay, so let's go. Our first question, like the question that we had was, how can we reach our goals and grow while maintaining teams' autonomy and flexibility? And the answer to that we reached was let's adopt this model based on chapters and squads. Other companies already use this. So for instance, Spotify and Facebook. And the idea here is that squads, they are groups of people that works toward a long-term mission. So they are autonomous, they are self-organized, so they can go to end-to-end responsibilities without really depending on other teams. And they are also cross-functional, distributed. The idea is that autonomy and alignment increase how teams can work faster with more motivation and also higher quality, right? Okay, so these are squads, and so let's give some examples of how this works here in Nubank. So all squads that you can see here on the screen, they serve to a bigger purpose, we can say like that is providing customers the services they need, but at the same time, as they are autonomous and have their own goals, they work independently. So for instance, you can have a squad that is focused on credit limit models, another one that authorizes purchases, bills, and so on, right? Okay, and so how does chapters relate to that? The thing is that chapters are a more intuitive concept. So engineers, for instance, is a chapter here at Nubank. Data scientists, experts are the folks that takes care of services, customer services, and business analysts that analyze data in order to take business decision. So the idea here is that every squad, they can have different chapters working on them, and that's why they are autonomous. They don't really depend on other squads. So far, so good. And if you're interested in that model and if you want to learn more about that, that's a really nice video in 2 parts in Spotify Labs. You can just check it out. Okay, but then giving more of an overview of how things developed here in Nubank. So as you can see here, we had a really fast-paced evolution in our employee numbers. So in the last 3.5 years, we went from, we grew 6 times actually. So as of today, this means that we have 33 chapters spread all over around 90 squads. But what about data-related chapters, right? This is a machine learning meetup. The idea is that we have a spectrum, and it goes from really engineer-related tasks to analysis. For sure, there's overlap here, but what we have here at Nubank, and this is work in progress, right? So things are dynamic, they change over time, is that chapters, they can be more engineer-focused or analysis-focused, but sometimes be part of both. Okay, so.
All right, so I'm now going to talk about the relationships between these squads and chapters and what it means in terms of data architecture and the kind of problems you run into. Okay, so Andre Tavares, who is in data access at Nubank, presented a few months ago, I believe in December, and he showed this slide. He was talking about the data infrastructure at Nubank. So for today, we're not going over all of that again, but I just wanted to show the big picture and what we are focusing on right now, and as a data analyst chapter. So the main thing we're going to focus on is the Spark engine, sort of left, bottom, middle. And another thing that's important to realize is the data that flows into the Spark engine comes from the production services. So a bit of context, what is a Spark engine? Who has heard of Apache Spark? Okay, so about half, I would say. Spark is a tool to process data in a cluster, large amounts of data. It also has machine learning functionalities. We're not using them yet, actually. I don't know if we are. I think we are exploring them. So we use that to process our data lake. Like we get data from our production services, we put them on S3, and we use Spark to process that. But in that Spark engine, actually a lot happens. And we knew in 2017, when we were building the system, that a lot was going to happen, because we were adding new products to Nubank. Back then, we didn't have the prospect of expanding to new countries, but there was certainly the desire to do that. At the same time, we were hiring a lot of data scientists, business analysts, PMs, anyone that does anything with data at Nubank, we were hiring them. And on the other side, the engineering side, we were creating more and more microservices that actually generate the data that you can use for your models. So we took this decision in the end of 16, beginning 17, that we wanted to encourage all the squads to be able to build their own data pipelines. Why did we do that? Well, the alternative would be to have a central data team, sometimes called like a BI team, for example, or a data engineering team. In that scenario, there would be one team that takes care of all the data modeling. So they need to have all the context in their head about the microservices and all the data that's being generated, but at the same time need to know how machine learning works, for example, like how do features work. So we didn't find that very appealing because it would mean with a team of 3 or 4 people in data infra at that time, we would need to know a lot of stuff. And we were expecting if we went down that route that we were going to block business analysts from getting the data they need to make a decision fast. And the same thing goes for machine learning. Like we wanted to empower all the data scientists and machine learning engineers to use the data that becomes available in a new product, for example, as fast as possible. So that's why we made this trade-off. So what does that look like? So what I'm talking about when we are empowering all the squads to take the data pipelines in their own hands, it means we have a GitHub repository where people are contributing their data transformations. So this is what we had yesterday. So 245 contributors, new bankers on this platform. And considering that we have like 1,500 employees, it's a pretty large percentage, which is very cool, especially considering that all of it is in Scala. So this is a bit controversial because it means that a lot of people had to learn Scala, even though like data scientists generally love Python more. So, well, but we managed to do it apparently. They also have no other choice. But so Scala everywhere. Now, but the reason why we didn't is not to, annoy people. Scala has some benefits. For example, Spark itself is written in Scala, so we want to be close to that ecosystem. And it's a strongly typed language, which makes testing easier. And we do want to test this very heavily, because we run our data pipelines at night, some of it, and we don't want to be woken up in the middle of the night because some data crashed. Who has experience with that, working at a company, crashing data pipelines in the night? Yeah, exactly. So we are trying to do as much as possible in the development pipeline to prevent that from happening. And thank you all the data scientists from Nubank that are here and learn Scala. Great job. They are actually building really cool stuff, really cool abstractions on top of our data platform, things we didn't envision before. So that's very cool. And yeah, in terms of pull requests, so contributions to the code base by the contributors, we have almost 5,000 pull requests. So pull request is a piece of code and someone saying, hey, can I make this part of the production code? So you create a pull request, make a description of what you changed and why you changed it, and then we do a peer review of the code to make sure that it's in line with our design and there's no obvious bugs. And the final thing about that, yeah, in the last month, we have seen 251 merged pull requests from 97 different authors. So a little before and after of what that looks like. So in 2016, we had 8 data sets in December when we started putting all the data stuff that we had so far into Monolith, the Spark Engine project. And a year later, 3 months, so last year, I don't want to know what it looks like today, but yeah, we created this visualization of all these data sets, and this is missing a lot of them too. These are just the data sets that are contributed by people at Nubank. So the nodes are tables, data frames, and the edges between the nodes are data set dependencies. Because the way these transformations work is you take some input data sets, maybe you join them together or you do some logic in them, and then it creates a new data set with a name. And we use a PageRank algorithm here, so data sets that are dependent upon a lot are bigger. The color of it means what squad owns this data set. So that was the decision we took. We have learned some lessons. Yeah, so if we reflect on that decision, Where we clearly won is in terms of data democracy. So that's sort of the buzzword that people use, which means everyone is able to access any kind of data. So if a data scientist thinks, hey, there's this microservice that nobody is looking at, it's generating potentially interesting data, let me analyze it. Maybe I can use it for my machine learning model. Well, that is possible with the approach we took. And you can build your data transformations, create a pull request, and it became part of our infrastructure. So yeah, I think we did great there, and also the speed. As I said, people don't have to wait for a central data team to come up with the right data architecture. No, it's as soon as it's available in a microservice, business analyst, data scientist, etc., can use it. Data that's not available, by the way, is the PII data, like personally identifiable information, such as CPF, name, those kind of things. You need additional permissions. Another area where we won is that we as a data team, data infrastructure team, were able to focus more on creating a solid platform while other people at Nubank built on top of that. Since we were only with a few people, this really helped. So we didn't have to focus on the ever-increasing number of microservices and number of data sets and machine learning models. So where we lost is, unfortunately, documentation. If you remember that graph, like there's a lot of stuff going on, and we don't have that much different kinds of data, but we do have a lot of different types of visions, perspectives on top of that data. There's a vision that the central bank wants to see, that we have to report to them. There's features, obviously, machine learning models. There's a risk view, operational view, a lot of that. So often you see the same column name, but it means something else. So we can do better there. And that also relates to the canonical source of truth. So source of truth is saying this piece of data from this microservice is what it means to be a purchase using your Nubank credit card, for example. It gets more complicated than that. But fair enough. And one that I want to focus on in this presentation is a bit more tricky. It's the tight coupling between microservices and business intelligence / machine learning models. So let me walk you through this one using a practical example. In this case, like how do we prevent analytical data or features getting out of sync when our microservices change? So we're gonna walk you through a diagram here. Are you able to read these labels in the back, more or less? Okay. So in the top left, we have an authorizer squad. That's the squad that is responsible for, like, if you do a transaction, do you have enough credit limit, for example? In the top right, we have the billing squad. This is half real, half fictional. It's simplified. Billing squad, they are responsible for anything related to bills, to customers, and analyzing them, etc. And we have a squad customer management. And squad customer management is responsible for offering the right credit limit to our customer. So what do they do? In this example, well, these squads do a lot of things, but billing has a dashboard, a BI dashboard, that they depend on for their analytics. And customer management has a credit limit model, machine learning model. I use the AWS icons, by the way. They look nice. So what do these business processes need in terms of data? Well, in here we have the bills data set feeding into the business intelligence dashboard, and we have a transactions data set into the machine learning model. So consider that transactions data set in the bottom, the features of that model. It's the same thing. I hope I can say that. On the left, we have the cards microservice. This is a microservice, a database, operational database that contains all the information about cards. So it probably contains the data if you open the app that it shows your apps. That responsibility is probably this microservice responsibility. And out of band here is a bills microservice in the top and a transactions microservice in the top. in the bottom that are being joined with the cards to create the features, and the bills are being joined with the cards to create the bills data set. Is anyone lost so far? I can explain more, especially when the labels are hard to read. Hands up. Okay, I'll continue then. Okay, well, let's look at a scenario. We now, in this fictional bank that looks a bit like Nubank, have debit cards. And our original microservice that fed into these data sets was called the cards microservice. But the engineers in Authorizer decide that it's not a good name. They want to split the cards in debit cards and credit cards microservice. So that's what they do. They keep the old service alive to make it easier to migrate data, and at the same time create these two new microservices. So what happens with these this machine learning model and this dashboard? Well, first we have to establish that the old one is deprecated, the old microservice. There's no more new customers going into that service. All the new customers are going into the credit cards microservice, if they're credit card customers. So the dashboard and the machine learning model are using incomplete data. Fortunately, we have strong monitoring at Nubank. So very quickly, the billing squad finds out that something fishy is going on. It's not showing a nice growth curve. It's flattening off a bit. So they go to the authorizer squad and they ask, hey, what's going on? Like, are we down? Are we not popular anymore? So they check that. They find out that this is the situation with the credit card microservice. So what they do, they add another input data set, and they are good now. They have the new data. At the same time, the data scientists in the customer management squad, together with the analysts, find out the same thing. They're monitoring the results of their machine learning model, and also they find that some weird stuff is going on, some anomalies. So they do the same thing. Well, now repeating in your head this, how many squads do we have? 80? Well, let's say half of the squads depend on this very basic microservice. And there's a lot of processes going on that are very similar in nature. Everybody has to make this transition from one data set to another. So let's clean this up a bit. After a while, they remove the cards microservice, remove the links, and we have a clean situation here. So as I said, there is a redundancy in this solution. Both squads had to do exactly the same kind of fix to get to the result without communicating to each other. So can we do better? Well, we think we can and should. So what if instead we require every squad to reinvent the wheel when something changes upstream, which will happen more and more? What if we add an interface, level of indirection? We add an interface in the middle. It says interface shared dimensions. What if instead we put a data set there? In this case, we use the data warehouse terminology from Kimball. It's a card dimension. And we offer this to squads. We say, oh, you want to know anything about cards? You want to enrich your features with data from the cards? Okay, use this. And if something changes in the microservices, we take care of it. We rewire if the engineers decide to refactor it again, or if something completely new happens, we add it there. And at the same time, we create these canonical definitions. Like we make sure that there's only one way, like the, I don't know, color of the card. It's purple. You can find it in one place. There are better examples, sorry. Let's see if this holds. So this is all working fine, but everything is working fine until we decide to change something. So in this case, let's add a new product. So now I added squad rewards in the bottom left. And we're going to add a rewards product to Nubank. So create a squad rewards and a place to store the data, the rewards microservice. And then wouldn't it be nice if the machine learning people want to use whether a card is part of the rewards program or not, having that data already available in the card dimension. So yeah, we should. And some of you might think, oh, that's scary. You know, you're adding data to a source data set of my model that might break it. Well, it's a very valid concern, and we are aware of that. At the same time, we can build a very thin layer on top of these microservices to make sure that we're not breaking stuff. And when we add new products, we add them as new columns, so they won't break existing stuff. That's our plan. So let's get rid of all of that and think about what we need. So in order to design this interface in the middle, you need to know basically everything. You need to know what data is being produced, but you also need to know how people, like what people actually need from that data. And this is not compliant with the squad model. Like we want everyone to be autonomous, distributed, own their own decisions. So that doesn't work. And that's where the Data Analyst chapter comes in. So we are a chapter. We are spread across all the squads. And we actually have the incentive and the authority of getting together, gathering all those requirements from the squads and understanding what's going on in terms of data that's being produced, and work together on that design. So that's what's going on. We have a cross-company alignment process in the middle that the data analysts take part of, and then we design these shared dimensions for everyone to use. So, summary, we have the start situation with the machine learning model and the dashboard. Then we created the debit card product, and we found that because of a refactor from the engineers, the data sets had incomplete data. Both squads had to fix it reactively. They found in their monitoring that something was wrong. So that's why we came up with this dimension layer. And it allows us to push data changes proactively to the squads. And we need someone to build that and maintain that for the long term at Nubank. And that's one of the things where the Data Analyst chapter is uniquely positioned. So why do we do all this stuff? Well, I was looking at the announcement page for this meetup, and we looked at the picture. So let's zoom in. And I saw the following on the slide. Can we make the data scientist focus more on the modeling stuff? Well, we don't know what the context is because I didn't see the talk, but thinking about this question, where we as a chapter can help, is taking all that domain knowledge from all those 300 microservices that are frequently changing out of the head of the machine learning engineer or the data scientist or the business analyst and abstract it for them. So they have more time. They can spend less time on like data cleaning, data integration, and more time thinking about modeling and neural networks and all those things that I don't know. So it's, yeah, now is a good time to do this. Because what we are proposing is basically centralizing again. And in the beginning, I said that we didn't want to do that because we didn't want to block people. Well, we are now, we're more stable. Time has passed. The number of microservices is growing really fast. It's more than 300. Yeah, and we have a lot of data sets being contributed on a daily basis. Also, we have regulation requirements that require us to present ourselves to those regulators, auditors, investors as one Nubank, not as a collection of squads that can have disagreement about what a certain piece of data means. So we need to do more on that, on those canonical definitions. Employee growth, people can be lost. There are so many data sets to find. So yeah, we should do something about that. And all of this stuff, all of this knowledge that is encoded in people's heads that have been at Nubank for a longer time, we can make that better, put it in an interface, have people, give people more easy ways to explore all the data that we have available.
Yeah, so now that we know already the whole context and how the chapter was created, let's take a deeper look into what a data analyst routine is like, okay? So about impact, that's something that were already mentioned by Pepijn. So our 3 pillars of impact, let's put it like that, is data modeling, the clarity of the data, and also tackling what we call the data gap. So regarding the data modeling, the idea here is that we can make the whole data warehouse less chaotic, adding that central layer that Pepijn was talking. Decoupling then the backend architecture from chapters and business logic. So regarding data clarity, it's the idea is that we must have canonical sources of truth, so we can help defining that and also documenting stuff. All of these, it will increase discoverability, and then as a consequence, everyone using the data, new bankers can have more creativity whenever they're dealing with data. And about the data gap, the idea here is that squads, they have different levels of data literacy, and data analysts can support them in all levels. So the overall impact of the data analyst chapter is that we can help new bankers go faster, work smarter, and focus on they are really all about, their role-specific matters. Yeah, but what about the role itself? Well, we are focused on engineering. It means that now, as we are in another level of maturity as a company, we want to build lasting solutions through code. And where does a data analyst do it? As of now, we already have data analysts working in squads such as working with continuous auditing, the finance squads, data access, which is me, AML and risk, but also it depends on the squad's prioritization and how much they need a data analyst, and of course the interest and the focus of the data analyst, like in the career-wise. So let's take a real life example now. Lending, for instance. The idea here is that people are creating a new finance platform, and the aim was to integrate lending-related microservices. And what happened is that was collaboration between the lender squad and a data analyst that were focused on that. So from day one, the whole process was taking into consideration business logic and business needs, as Pepijn was showing, is the same thing. And also we focused and we built long-lasting solutions. So we added at the end of this monitoring and alerts that would be triggered if something went wrong. So basically reconciling it automatically. What about the challenges that we have? Because it's not all roses. So we're growing fast as a company and also as a chapter. So one challenge that we face is making sure that we don't become disconnected, because if we do, we kind of lose our core there. So what we do, the solution that as of now we have is making sure that we have communication and meetings. So we have a specific meeting, we call it TGIF. So every Friday we get together, share knowledge, make mock programming sessions, talk about challenges that we had and some things that we should be focusing on. Another challenge is, as of today, we don't have a data analyst in every squad here in Nubank. So how do we guarantee that we can share knowledge and understand what is going on? So what we do is whenever we detect a specific problem, we tackle that with task forces, and also through data training to the whole company. And another challenge, and this is a really important one, is that it doesn't matter if we build a really nice solution if it's not user-friendly, because people will just like not use it at all. So what we do is trying to make our solutions as close to the business needs and people's necessity, Nubankers, as much as we can through shared dimensions, and also in collaboration with Data Access Squad, monitoring queries patterns. And what do I mean by that is that we actually check, it can be creepy, but it's true. We actually check query patterns. So whenever a new banker start using and querying some new data sets, we can actually go to query logs in BigQuery and check how they are using the things we created, so we can build even better solution based on what we see from data. What about the skills that a data analyst must have? Well, it's a lot about empathy, because we do have to communicate through squads and teams in order to understand what are the problems and be this bridge that we were talking about. So there's that, and also being able to deliver a solution all the way to production. Well, regarding other skills, we are focused in programming, so it's important to have a programming and a data manipulation background, knowledge of data modeling concepts, and stuff like that. Well, other stuff that we can learn, like on the job, are software testing, functional programming, and also continuous integration, stuff like that. Well, we have already covered a bit that, but technologies and tools that we use, so there's BigQuery. This is actually, we are migrating now from Redshift to BigQuery, so there's that. Also Databricks, Looker is our BI tool, official one, and also Scala with Spark, as Pepe explained, and also Python for some analysis, and also Clojure, which is kind of optional because it's the main programming language for engineers here at Nubank. And regarding career opportunities, because spoiler alert, even though machine learning and engineering and data science are not with open positions, we are. So there's the international aspect. We have a highly multinational team. This is like a, and also the international, with the international expansion from Nubank, there's the multinational ETL and stuff like that, really interesting. And also, of course, like if you're a data analyst, but you want to be more focused either on an engineer or an analysis heavy path, that's always a possibility. Okay, so we have talked a lot, and this can be very overwhelming, but we have a full structure onboarding process to make sure that all new data analysts have the training that they need, the context, and everything like that. So this is the team, that's us. And if you're interested, if you like everything that we talked so far, we're hiring, and there's the link for our careers page. And that's it, thank you.
Compartilhar o microfone. Vamos lá. Hello. So now I'm going to read the most voted questions, but we still have time to upvote the ones that you find that's more interesting. Okay, so the first one is, how is the data analyst hiring process?
So the hiring process, yeah, we just open again. So we have a couple of steps. The first step is, well, application of your resume. We check the resume. If we like it, move on to the next step, which is a HackerRank exercise, so coding exercise, because we think coding skills are very important to create these lasting solutions. If that's an okay, we do a phone screen of 30 minutes. After that, a case that you can prepare at home. And yeah, if we like the case, you send it before. We invite you to the office, and there's a 1 hour session where you present the case, and we have a discussion about the thing that you implemented. And on that same day, there's also a chat with people and culture, which is our HR team, to get to know each other better.
Okay. The next one is, what are the tragedy challenges building ETL pipelines? Tragedy challenges.
The tragedy challenges.
does
Not
it mean?
entirely sure what that means.
I think you can just say about challenges. I think tragedy is just...
Okay. Okay, so the challenges we faced. Well, first of all, like working with an ever-expanding number of data sets, an ever-expanding number of data volume is a challenge in itself. We don't use Elastic MapReduce, for example, from Amazon. We host our own Spark cluster for reasons. So it's always a fight with the cluster, and we're getting it under control. But yeah, heavy data sets, like since people are able to contribute their own data sets, sometimes there's like a hot partition and it still crashes at night because it's really hard to find these things when testing. So yeah, that is one, like the cluster breaking, and yeah, that happens at night because that's when we process our data. So yeah, that's a tragedy challenge. We now have the data infra team in Berlin, and so we win some hours because of the time zones. So if they start their day, I don't know, 8, 9 a.m., it's 5 hours, it's madrugada here. So they have some space to fix issues as they occur. And we're getting more and more stable because we're not just fixing it, keeping the cluster alive and then next day it happens again. No, we do postmortems. So if something broke, we have a session together and we figure out what went wrong and how we can prevent it from happening in the future, and then build software as necessary or change it to make us a bit more robust. It's challenging. Does that answer sufficiently? We have more like tragedies.
Okay. Why are you moving from Redshift to BigQuery?
So we're moving from Redshift to BigQuery because of a number of reasons. First of all, we have a lot of concurrent users accessing data at the same moment. And the Redshift concurrency model is old. Like Redshift is based on some Postgres from the Stone Age, and it doesn't support concurrency very well. So that's one reason. BigQuery has a different kind of model where I think they decoupled the storage from the compute. So it works better concurrent. Another reason that I personally really like is the ability to use complex schemas. So in Redshift, basically every cell in your table has to be like a string or decimal, etc. But BigQuery, Spark, Snowflake, all these modern tools support complex schemas, which is a bit like a JSON object, but not a JSON object. It compresses still really well. And it allows us to become much more creative in our dataset designs, much more user-friendly, which will especially help with these shared dimensions that we're planning to build. So yeah, just what is a complex schema? So you can nest things inside a cell. You can use arrays. Yeah, that's basically it. And you can build a lot of stuff with those two things.
And how the usage of Clojure and Datomic on the backend affected the way you conduct your data analyst projects?
The use of Clojure in the backend, how that affects our data analyst
Yeah, how
projects?
does it affect your work?
Not a whole lot. We, as of today, we live on the analytical side of Nubank. But if I may interpret that question a bit freely, we have something that's really cool, which are the contracts. And I think André Tavares explained this in December. But basically, since all our microservices are written in Clojure and use Datomic, we have a very like a thin layer to create the tabular representations of that data. So what that means, Datomic is basically like a graph database. It uses triplets to describe data. So it's not like a table. But since we're using Spark, we use Redshift, BigQuery, we need to transform that data. And that's what we call contracts. So from the schemas that we use in production in our microservices, we are able to generate these contracts and turn all of that into Spark data frames. So that's how we get to, for all these 300 microservices, we have maybe like 4 entities per microservice. So we get 1,200 tables already by doing nothing at all.
Okay, so there's this question of terms that I don't know, so correct me if I'm wrong. Do you use a specific methodology like CRISP-DM or TSDP, or do you use any in-house methodology?
I don't know what these terms mean.
So,
what kind of?
Gabriel, do you want to clarify your question? Yeah.
Actually, I wasn't aware that you were not from the data science team. So the data science process is a process to do data science. So I think that's why you don't know. So yeah, and CRISP-DM is something like that.
Do you know it?
Yeah, I'm a data scientist and I also don't know, but it's okay. So the last question is about how do you manage the workload from chapter tasks and squad tasks? Like we see that the data analysts have to group and work together for a while, but they also have their squads. So how do you manage the tasks?
Yeah, so we're a young chapter. We're finding all these things out as we go. And we look at experiences in squads so far and see what people are doing, see if people are happy, if it's in line with the career they envision. So far, like really positive. I'm really happy because we wanted to keep it intentionally vague a bit because of this data gap that Talita was talking about. Like we have a lot of things to do in terms of data, like from documentation to building data pipelines to making it more scalable, to teaching people even how to use the data. So I think data analysts can help in a lot of aspects there. But in the future, this is probably going to be challenging because we want to have both that effort to integrate all the data, which is pretty time consuming, and at the same time, the squad has their demands on whatever they need. So we don't have a strict protocol yet. We go sort of data analyst by data analyst. We are 11 now. And yeah, and we are very focused on this, and we want to make sure that it's not like some people are overloaded and completely lost from the other data analysts. No, we want to keep everyone close together because that's what we need in order to be successful in creating those data interfaces. Yeah.
And there's also something to complement that is that squads also are aware of that, about how we work usually. So for instance, the onboarding process, although we have like a more intensive week, it can last up until like 3 months before a data analyst is actually deployed in the squad that it's going to be. So they are already aware of how we work. So there's also this understanding from their part.
There are more questions, but we're going to stop here. So Pep is not going to stay with us for the happy hour, but Talita is going to be here. So if you have questions about the data analyst chapter, you can talk to her at the end. And that's it. Thanks.
There are also other data analysts in the room. Maybe you can raise your hand so
you can
people
raise.
they're all in that
look at there.
line.
There are a lot of data analysts there.
And should you have any other questions, I think these slides are going to be public. So yeah, my name is easy to find on LinkedIn. So if you have questions, go ahead. It's hard to pronounce, but I don't.
Okay, great. Thanks.